All right, so we're going to look at trigonometric functions at any angles. So what this is going to do is it is going to take the right triangle trigonometry you're doing and the coordinate plane and combine them together. So we're going to take and mix the two. So if you look, for this one here, we have an angle in standard position, so don't forget that positive x-axis, right? And then the terminating side here, always, the angle is going to be formed here at the origin. If you remember back from geometry, the standard form for a circle in the coordinate plane, now this one has the center of 0, 0, so there's no parentheses here, but x squared plus y squared equals the radius squared, r squared, okay? So this is what our 6 trigonometric functions will be. So sine's always going to be y over r. And if you think about y, and here's one that's drawn for you, it's that vertical distance. So it would be up the y-axis, right? And over the radius there, because that's your hypotenuse. And then cosine will be x over r. And again, here we have that horizontal distance and r, the hypotenuse, okay? So you're always going to be able to drop to the x-axis or go up to the x-axis and make a right triangle. So even though we're talking about the reference angle, or the angle over here, we're going to use this little angle that's going to be formed here. We're going to talk more about it. It's called a reference angle here, to make these trigonometric functions. Okay, and then again, your tangent will be y over x, and then we'll have those reciprocal functions from the first 3, okay? And then again for these, just do watch, you cannot have 0 for the x or the y if they are in the denominator. Your radius will never be 0 because that's not possible for those. Okay, so let's go ahead and take a look at an example to start with. So again, let -4, 3 be a point on the side. So go ahead and label that your x and your y of our angle theta. So you want to draw a little picture of that. 1, 2, 3. Let's say -4 is here. And we'll go up about 3. So when you draw in that angle, it's going to look like that. If you want to make the arrow, feel free. So we're going to draw in the triangle that would be formed here. Okay. So notice you're always going to be able to have a right triangle being formed. Whatever the y is here, that will be the side here. Your x value, that's going to be the side of the triangle over here. No, I wrote 4 when it's 3. Okay, so the side here is 3, this side's -4. So the first thing, because it's a right triangle and we're missing the hypotenuse, let's go ahead and find that. And then you can always do Pythagorean theorem because we have our 2 sides. Okay, so that's our formula for that. Go ahead and finish it. So that's your r squared, so r is going to equal 5 when you take the square root. So now we have the 3 sides that we need for our triangle to set up our 6 functions. So let's start with our original 3 that we have. So we have our sine, theta, cosine, theta, and tangent. Okay, so again, we're going to use the acute angle here. So for sine, opposite over hypotenuse. Cosine, -4 over 5, because it's the adjacent over the hypotenuse. And then lastly, our tangent, opposite over adjacent. And once you have those set up, it should be pretty easy to get the next 3 because you're just going to take the reciprocal. So there's our cosecant, our secant, and then lastly, our cotangent. Okay, and there's your 6 functions at any point. So let's try the next one here. So we have another example. So we're going to do the same thing. We have our point 8, -6 given. So our x and our y. And we're going to first draw a picture. You don't have to draw the picture. I just think it helps to see. So if we go out, let's see, 8 here, down -6. Now for this one, to make the right triangle, you want to go up to the x-axis for that. Okay, so these triangles you make should always be formed with the x-axis and then to the origin here. So your right angle will be there. So we know that again, this side is 8. No, it's not, sorry. That side's -6, excuse me, that's the y value. This side here is 8. I'm going to erase that 8 because that's confusing. Okay, so we have our x value, again, the horizontal, and our y value, that vertical. Okay, so again, Pythagorean theorem. So our radius is going to end up being 10. And now we have our three sides. Let's go ahead and set up our functions. So starting again, this is going to be the angle we're looking at here. Even though this theta is referencing the large angle that we used to form it, we're still going to use the acute angle of the triangle. So we're going to do our opposite over the hypotenuse, so negative 6 over 10. And you can reduce that down. Take a 2 out of each one, negative 3/5 cosine theta. So our adjacent over hypotenuse, so 4/5 when we reduce that. And then lastly, our tangent. Okay, so tangent opposite over adjacent, so we're going to have negative 6 over 8, reduce that. Okay, there's your first three. And then we're going to do our reciprocals, so our cosecant theta, just flip, take the reciprocal of that one. Secant theta, take our reciprocal here. And then lastly, cotangent, we take the reciprocal of that one. And that is how you find your trigonometric functions of any angles. So if you do see on the bottom of the notes, I did post that blank unit circle. There's a Desmos activity. There's very special angle measurements I want you to take a look at and to see what the coordinates are that correspond. Start filling out that circle. We're going to talk more about memorizing it. It's really important for trigonometry. And then the back of the notes, we're going to go over a little bit more with those for part 2.